Hello, grade 10. Here we are again. And what we're going to learn today is we're going to learn how to find the arc length and the sector area of a circle, okay? So arc length is what I've outlined here in purple. This is the length. So this, as you can probably tell, is part of the circumference. And if you remember, the formula for the circumference is 2 pi r. The sector area is just this. It's an area which is part of a circle. And just to mention, this is a minor arc, and the unshaded would be the major arc because it's longer. This is the minor sector, and this would be the major sector. Just a bit of trivia. So how do we do this? Let's start with the arc length. So arc length, we said, is part of the circumference, okay? So when we need our formula for this, that's what we're going to do. We're going to do the circumference formula, but we don't want the whole circumference. How much are we going to want? Well, here we're going to want, think about this as a whole. The circle has 300 degrees, 360 degrees, and we're going to want 60 of it, okay? So we are going to want whatever section of 360 our angle will be, okay? So your formula is whatever this angle is out of the total of the circumference. If you want, you can right now try to write down the sector area of your own. Perhaps the logic has already allowed you to do that. We're going to have the pi r squared formula, but again, we don't want the whole area, but we want however much our sector is taking up, okay? So let's apply this to an example. Here we are. So find the arc length of this. Okay. So our arc length, I'm just going to put L for length. So we're going to have 60, 3/60th of 2 times pi times the radius, which is here 8. Okay, then we're going to go to our calculator, and I already have it here because I was having a previous try with this podcast. So we're going to have 60 3/60th, 2 times pi times 8, and you see that we have 8.377, okay? So our answer to at least 3 significant figures is going to be 8.37, and I'll do 8, okay? Since this is a length, then our units are just centimeters. Now, if you want an exact answer, which is a little bit fancier, just go ahead and type the whole thing in again, but just don't put the pi in, yeah? And then you'll see that you'll end up 8/3. If your calculator is giving you a decimal, remember that this ABC button allows you to convert between decimals and fractions. So it'll give you 8/3, and then you can just go ahead and put an pi next to it. So our exact answer is 8/3 pi. Okay, let's do the sector area. Similar process. So again, hey, can you give me 60 3/60th of my area? Okay, and then you can go ahead and enter that. So 60 3/60th of this, and you get 33.5. And if you wanted the exact answer, which is always better, but it's not a requirement for us, you would end up with 32/3 pi. So in terms of pi, okay? So hopefully the logic of that formula makes sense. Let's take a look at the next question. So a sector of a circle has a radius of 10 and an arc length of 15. Find the angle. You know what this is, don't you? So this is moving past those level 1, 2 problems where they're asking you to find one of the other parameters and they give you the quote unquote answer. So they tell you the arc length and we need to find the angle. Not a problem. We're going to just go ahead and use our formula. We're in the sector, so we have, just going to substitute it in right away. So we have 15. I underlined that for no reason at all. And then we have theta 3/60th of the circumference. So 2 times pi times 10. Okay, a little bit of work here, so we're going to do 15 times 360. I'm just going to bring the 360 up. So it's 5,400. Is equal to, and then you can just go ahead and get a decimal for this. Can you see that this is 20 pi? Theta, or if you want to, you can just do this as a decimal right away. Okay, so this is like 62.83, and so we want theta, so we're just going to have, and we're going to go ahead and divide by this value. Keep the whole thing in your calculator. It'll prevent you from being a little bit off due to rounding. Miss Walsh. All right, so we got 85.9, sorry about that. So this is the size of our angle, okay? It's not drawn to scale. Probably you already saw that there's no way that this looks like it, that it's this big, but yeah, we'll just accept it, so not to scale. Okay, so just to summarize, what did we just learn? Sector area, just take whatever part of the angle it's taking up of the area. For the arc length, take whatever part it takes out of the full circle of the circumference formula.